if you are crashing feet first into something, all of you intuitively know that hitting the track pad is going to hurt less than hitting a brick wall of ice or a wall of ice. There's going to be some pain involved in smacking into something very solid. What is likely to happen when you hit the wall?
Stop.
You're going to stop. Your legs are going to buckle. Are they not?
Oh, that would hurt.
Okay. Unless you lock your knees, your legs are going to buckle.
He didn't bend down.
So we have a couple of things going on here. Let's go back to another question that we had asked. How long does it take for two things to collide? So how long does it take for you to collide with the ice wall? Oh, it's pretty darn fast. It's pretty darn fast. It's going to hurt.
Try not.
Oh yeah, I'm sure you'd lose consciousness. How long does it take for you to collide with that track pad? That big old crash pad. Is that going to take a little bit longer?
Yes.
Interesting. Interesting. Now, here's another question. Let's say you're colliding with the ice wall. If as you collide with the ice wall and your pretty little luge toes meet the ice wall and your legs bend, is that going to take a little bit longer
Yes.
than if you lock your knees?
Oh. Don't even say that.
Sorry. Oh yeah, sorry. This is probably a little bit too close to home for you, isn't it? Okay.
Just imagine.
Yeah.
Really
Really
Oh,
bad.
God.
Oh, Marley's gonna watch this at home all by himself. The terror, the pain, the anguish. Okay, so
Let the sled.
let's go back to this question. How long does it take for two objects to collide? So you all said it depends. It sure seems to. So you're saying that it would take longer to, except for you,
Same analogy.
that it would take longer to collide with the track pad than the ice wall. You all also seem to intuitively think that it would hurt less. Crazy, crazy people. Wild and crazy people. Okay, so there seems to be some connection between the amount of pain that you're expecting and how long this collision is going to take, yeah? This is exactly what we want to talk about. This whole thing is moving a little bit slow this morning. So, what would you say the relationship is between time the collision takes, and we can use pain of the collision as a proxy for force generated by the collision. What would you say that relationship is? Inverse or direct? How long the collision takes. So if the collision takes longer, does it hurt less? So that's what kind of relationship? Inverse relationship. Okay. In fact, that's exactly the case. And we said the amount of pain that we're expecting is directly related to the amount of force that's going to act on us. We are actually going to do a mini construction project for this chapter. Mini. It'll be a one day, you walk in, you get your materials, go. And it relates to this very concept. So how can we reduce the force exerted on the object in a collision? Make it take longer. Are you familiar with what a crumple zone is in a vehicle? Any of you ever seen a vehicle that's been in a front-end collision? Okay. The front end of the vehicle does what?
Crumbles.
It crumples! Was that given away by the use of the term crumple zone? No? Okay. They tend to accordion. So here's the thing. In the 50s, those big, beautiful American cars, 55 Chevy, anything like that, did not have crumple zones. They were good, hard American steel. Guess what happened when they hit an object head on? You had a much higher fatality rate. You're much more likely to survive a head-on collision in a modern vehicle than you were in a vehicle from the 50s, 60s, even the 70s. I think they really started to use crumple zones in the 80s. What happens when the front end of the vehicle crumples? What are you really doing there? You are extending the time of the collision, which reduces the amount of force on the occupants of the vehicle.
Although it's still
It's still not something that any of you want to experience. I hope none of you ever do, and I really hope none of you ever experience a head-on. Anyway, what you're doing is extending the time of collision. So, any time that you can, in essence, slow down the collision, you're going to reduce the forces on the object. Now, do you want to know what your mini construction project's going to be? That's a mini, yeah, I'm going to walk in here. Okay. Have you looked at the events? Egg drop. Bingo. So, you are going to be creating a vessel in which to drop an egg. I'm still trying to figure out where we're going to drop it from. I'm hoping to get the gym and the announcer's tower. Oh, no, we want up. We'd go outside if we could, but it's too cold for that.
The egg would freeze, and then the egg would
The egg would freeze, yes. We will make a physics omelet with whatever's left of the losers. I figured you'd be okay with this. Yeah. Physics omelet?
Oh, wait, if you survive, then you still have that.
Well, you'll see. Trust me. They do this at Physics Olympics every year. They make a physics omelet during the egg drop with all the losers.
We could have all that hot fun Sunday too. For the nitrogen.
No. Okay, so anytime you can extend the time interval over which a collision occurs, you are reducing the forces on the object. What are some good strategies then for protecting your egg? Crumple zone, if you can.
Break zones.
How you make a crumple zone for an egg encased in paper and tape? That's for you to figure out.
Oh, paper.
We will do mass of carrier, so that the object that can get an egg to survive the fall that has the lightest mass will be our winner. And that will be the team that goes on to compete for us in egg drop at Physics Olympics. So, probably Monday or Tuesday of next week. Oh, no, not Monday. Probably Tuesday. Probably Tuesday in the second half. Actually, maybe we should do it tomorrow.
Yeah, let's do tomorrow.
You know what? We're going to do it tomorrow. We're going to do it tomorrow. Okay. So, here's the other part of that. So if you can change that time of collision, you can change the force on the object. If you change the object's momentum in some other way, you also change the force on the object. What are the two factors that change momentum? Mass and velocity. So if there's some way to change the mass and velocity, that changes the force. We'll keep that one in the back of our minds and think about it. Okay. I know I have at least one baseball player. Do I have more baseball players than that? Two? Morley, Ethan? Okay. Okay. But for the rest of you, have you ever caught something in your hand? Has somebody ever thrown something at you? You know what's coming.
Oh, I'm already. I'm a swimmer.
You were into the baseball.
You're on the baseball. That's why
I
I play
wouldn't
sports
grab
I
a
can't
baseball.
catch.
Whoa!
Oh!
Whoa! You gotta calm down.
I am done. Oh my god, dude. I play sports where I don't have to catch stuff. So I have to catch stuff.
Yeah, me too, because I'm lousy at catching. I'm okay at throwing. I'm terrible at catching. That's why I'm on this end of things. Okay.
I have like 2 fingers on it. That's all.
All right.
We need a bat.
Oh, man.
Why are we throwing things around?
Ooh.
Woo!
Even got some.
Good job.
Ooh.
Now,
I was like,
we are throwing a very light object around. This is pretty light. The wiffle ball is even lighter. So, if we can imagine for a moment that this has got a little bit more mass, what position do you play? You pitch. Okay, all right. I'm not lucky enough to have anybody in here who's a catcher, huh? Does Morley catch? Darn it! I wish he was here. Okay, but you've obviously you've caught balls thrown at you. Have you ever played And this is why I don't play. Have you ever caught something barehanded? How's that feel? Baseball thrown at you barehanded, you don't really want to catch it. No, stings like all get out, doesn't it? Because the ball has what? It's got mass and velocity, it's got momentum. It is colliding with your hand, therefore it is exerting a what on your hand as your hand stops it? Force. Stings like all get out. Now, you will do something instinctively as you catch that baseball to lessen the sting. You will give, other than scream, you will give with the ball. Not a whole lot of give with a wiffle ball. Maybe I should go back to playing.
Ooh, that's nice.
No, I'm still bad. That was luck. So tempting when they're not making eye contact. Okay, so you instinctively move your hands as you catch an object. Same thing if you've ever been in the path of something large, like a friend, a sibling, a large dog, coming at you. As contact is made, you instinctively give a little bit. And what you're doing there is doing what? Extending the time of collision. Okay.
For the tornado hits the house, and you got, maybe you got knocked out before the tornado.